Alright, today we're going to talk about some kind of formulas that you should be used to or familiar with seeing, and we're going to use those formulas to solve different types of problems. These are the different shapes. Now these first first three you should be familiar with: the parallelogram, triangle, and trapezoid. The rhombus and kite you shouldn't have, maybe you've seen them, but we're going to work through these. These are the formulas. I just went ahead and put those all together at the beginning, and then we're going to be using these to solve different things. Do remember that a square and a rectangle are considered parallelogram. So when we have square and rectangles in our problems, I'm going to kind of refer to this area is equal to base times height for the square and the rectangle. Also remember that the perimeter of a square is 4 times the length of the side. Right. So we'll start off kind of simple. We're going to look at this first parallelogram here. Find the area of the parallelogram. Remember that area is equal to base times height. Right. My base and height are always perpendicular. Right. So this is an important thing to remember. The base and height, regardless of the shape or the polygon, the base and height are always perpendicular. So for this one, the area is going to be equal to the base of 12 and the height is 10. So that is going to give me 120 centimeters squared. Now it's going to be very important, and I will count off on this if you don't use your units. Anytime you have units, you must use them. All right, next example is going to be a rectangle. And find the height of a rectangle in which the area is 10x squared feet squared. All right, so again, area. Now it is a rectangle, but it is a parallelogram, so I'm going to use base times height. The 2x would be my base. We need to solve for the height. All right, so I'm going to substitute the information I have. I know my area is 10x squared, and that's equal to my base of 2x times my height. All right, so now I can take this base, and I'm going to divide both sides by the 2x. Okay, these factor out, so I just have an h on the right. 10 divided by 2, that's going to be 5. I can factor out a 5. And if I have x squared, remember that that's x times x. So I can take one of those x's out from the top and the bottom. So that's just going to leave me 5x. So my height is 5x feet. Alright, next example, find the perimeter of a square in which the area is 169 centimeters squared. Alright, so I have some square, and I want to find the perimeter of that. So that's some distance s all the way around for each one. Alright, so my perimeter is going to be equal to 4 times s. Alright, but in order for me to figure out what that is, I need to know what each side is. So remember that the area of a square is side squared. That's the formula. I know my area is 169, so I'm going to take 169 is equal to s squared. And I want to get rid of the exponent right here, so that means I have to take the square root of 169. So that means the side is equal to 13. Okay, now that I know my s is 13, the perimeter is going to be equal to 4 times 13. Which is going to be 52, and then centimeters is my unit. Okay, so a lot of these problems that we're working with, yes, we've done area and we've done perimeter before, but we're going to kind of mix them together, and we're solving for different things. Sometimes I'll give you the area, you have to solve for the side or for the height. Let's look at the trapezoid next. Okay. Now, for this one, the area is equal to base 1 plus base 2 times the height divided by 2. Right, remember what I said about the base and height being perpendicular. So this thing you're going to have to kind of turn it, where this would be your base, and this is your base. This is 20 is going to be your height. All right, so for this I'm going to have 9 plus 15 times 20, and I want to divide that by 2. Alright, so multiplying 9, adding 9 plus 15 times 2 gives me 480, and I divide that by 2. My area is going to come out to 240 meters squared. Okay. Now, next example is a triangle, and I want to find the base of the triangle in which the area is 58.5 inches squared. So again, area is equal to base times height divided by 2. So again, you have to look at what information they gave you. So they gave you the area, and they gave you this 9. Now the 9 is referring to the height, so you're going to have to look for the base. Alright, so I'm going to do 58.5. I'm going to substitute what I know. 58.5 is my area. My base I don't know. My height is 9, and we're going to divide by 2. So first thing I'm going to do is I'm going to get rid of this denominator. So that means I have to multiply both sides by 2. Right. These factor away, and so this is going to be 9b is equal to 58.5 times 2, which is 117. I divide both sides by 9. The base is going to come out to be 13 inches. Right, so my base is 13 inches. All right, next example is rhombus. We want to find the area of the rhombus. Now remember, the area of the rhombus is going to be equal to diagonal 1 times diagonal 2 divided by 2. I want half of the diagonals. All right, now this one's going to require me to do a little extra steps because I'm going to need to find out this diagonal that goes across here. All right, so you're going to have to kind of refresh your memory, look back at different properties of the parallelograms. One of the things that we talked about is that these angles, the diagonals, intersect at 90 degrees. All right, and they bisect each other. So I'm going to end up having to use Pythagorean theorem to find the diagonal. All right, so again, since the diagonals bisect each other, if this diagonal here is 14 inches, then half of that is going to be 7. All right, and then this part right here, I'm going to have to figure out what that is. So I'm going to let that be x. Right, and then so my formula, my Pythagorean theorem tells me that I'm going to use 7 squared plus x squared is equal to 25 squared. Okay, so that's going to be 49 plus x squared is equal to 625. If I subtract 49 from 625, we get 576. Okay, so then I have to take the square root of 576. Which comes out to be 24. And that'll be inches. Okay, but that's only this part of it. So if I want the total diagonal, if this is 24, then this is 24. Okay, so one diagonal I know is 14 times my second diagonal is going to be 24 plus 24, so that's 48. And I want to divide that by 2. So the area is equal to 14 times 48, because this diagonal has a length of 14 inches. This diagonal is going to be 48 inches. 14 times 48 is 672. If I divide that by 2, we get the area is going to be 336 inches squared. Alright, this next problem is a kite, and the area of a kite is diagonal 1 times diagonal 2 divided by 2. Right, and they gave us one diagonal, looks like. So we have to find the other diagonal. So again, I'm going to use what I know. I know the area is 187.5 meters squared. Okay, I'm going to use 15 for diagonal 1. I'm still looking for diagonal 2. Divided by 2, so I'm going to multiply by 2. $187.5 times 2 is going to give me 375 is equal to 15 times the diagonal 2. 375 divided by 15 tells me that my second diagonal is going to be 25 meters long. Alright, example 8, the sign manufacturer makes a yield sign by cutting an equilateral triangle from a square piece of aluminum with the dimensions shown. And we want to do, the first thing A, we want to find the height of the yield sign. So since it's equilateral, I'm going to kind of draw this over here so I can draw on the picture. I know this is 36, and I want the height, which is going to come down straight here, at a 90-degree angle. Now, because this is an equilateral triangle, I know this has to be 60 degrees. All right, so this height is going to cut this 36 in half, so this piece of it is going to be 18. All right, and then using my trig special right triangles, if this is 60, this angle right here is going to be 30. So if this is 18, this height right here is going to be 18 square root of 3. So I need to do 18 square root of 3, and it says round to the nearest tenth, so we'll put that in the calculator. That is going to come out to about 31.2 inches. Okay, now so I want to use that to find the area of the sign. So area is 1/2 base times height. We know the base is 36. My height we found to be 18 square roots of 3. I'm using the 18 square roots of 3 because I'm going to round at the end. I want to make sure that I round at the end. So it's going to be 561.2 inches squared. Okay, and it says how much of the material is left after the sign's made. So since it's a square, the area of the square is going to be 36 times 36, or 36 squared, which comes out to be 1,296. So I'm going to subtract the 1296 minus the 561.2. And we get that that is 734.8 inches squared. Okay, so that would be my answer for part C.